3.3. Oh, this is going to be tough. So surface area. So when I'm talking about surface area, I'm talking about the total outside area of a 3D object, okay? Like my water bottle, it would be the whole outside skin of it, okay? Typically for surface area, you would do it for things like if you're painting something, figure out the surface area so you can figure out how much paint to buy. Or if you're tiling, they'll talk about like putting tiles on a wall. We did some of that, figuring out cost. Yeah, okay? And you go from there. Okay, so I will get you guys a formula sheet that has all the area formulas on it. But some of the major ones would be like for a rectangle, length times width, right? Area of a triangle, half the base times the height, right? So those are for, that would be for just a one-dimensional object, but sometimes they'll be used for making up a 3D object, like a cube or a triangular prism of some kind. Okay? Other ones that you might see would be like a cylinder. Did I spell that right? Or is it CI? No, I got it. So the area of a cylinder, surface area of a cylinder, is just, gotta make sure I get this right. All right. Now, with a cylinder, see how there's two parts to it? This first part, RH. Yeah. Cylinder. What's that, Jess? Okay. So a cylinder. That's some kind of shape like that, right? With your height here. This is your radius. Now the first part of this formula, and I'm going to highlight with the green underneath it. Yeah. Draw a circle, draw two lines down from this, and then draw half a circle around it. So this first part here that I highlighted in green, that's actually for the top and the bottom circles. Pi r squared is just the area of a circle. You times it by 2 because there's two circles. Okay? And then this 2 pi r h, this part here that I'm going to line in red, that's for, yeah, like the walls of the cylinder. All right? Don't say that one. All right, so anyways, so that's how that works. All right, any questions? Good. All right. It's just for, no. Okay, but it's all color coordinated, so you should be able to follow. All right, now, that's how you guys find the area of stuff. Yeah, a green top and bottom, red for the sides. Now, sometimes, like if you're finding surface area, like let's say I wanted it of an object, and the cylinder is like a pillar in the middle of a building, like this. I don't have to do the top or bottom, so I can eliminate this part here. I don't have to do the 2 pi r squared. Okay? All right, any questions? Cool. Everyone think they had to get up there? Oh God, I'm late. We should also do, bye Jesse, area of a circle, ties in nicely, is just pi r squared. The sphere is a little bit different. It's 4 pi r squared. Not right now. We would do more of that for like volume. Okay? And then cone. So for cone, so I'm talking about cone, right? Something like that. Cone. Oh, I see. I'm pretty sure it's cone. Area. All right, area of a cone. So you got a circle on top. It's more of a pyramid. It is. This one's going to look a little different. Yeah. So it's times S. S means, yeah, what'd you say? Side height or slant height sometimes. Okay. And now what your slant height is actually. So this would be your radius, right? The measurement from the top all the way down to the bottom, that's your height. But your slant height is actually, I'm going to highlight it in blue. From here to here, this length here, that's your slant height. So to calculate your slant height can be a little tricky at times. But basically, slant height, if it doesn't give you it in the equation, if I was just to draw this out, like take a cross section, if I was to cut this cone in half, it would look something like this. Yes, it would make a triangle. Very good, Danny. Where my height and my radius, and there's my slant height. Oh, Danny is killing it. And yes, my slant height is now my right. So the easiest way to calculate hypotenuse, I know, Thea, is to use Pythagoras. A squared plus b squared equals c squared. So you just do it like this. You take your height, you square it, plus your radius squared. No, no. We do that at the very end. Okay? So, that's how this works. These are the formulas for now. I'll get you guys a formula sheet. I thought it was on that one, but it's not. We'll learn temperature, I think, in Unit 4. Fahrenheit. Absolute zero is Kelvin. Go ahead. Negative 273 degrees. So cold, everything stops moving. It freezes all atoms. Yeah. Scientifically, we haven't been able to achieve it yet. Oh, yeah. Okay, let's do a couple of examples. Tin can. Diameter. Yeah, it's a diameter of 4 inches and a height of 5.5 inches. Yeah, yeah, yeah. How much tin is needed to make one can? Yeah, yeah, yeah. Don't come at me. So when I'm talking about the tin needed to make a can, I'm talking about the outside area of a three-dimensional object. Right, Hayla? Can you turn your solitaire off, please? Thank you. Take the example down.